Good morning, everybody. My name is Piotr Kaluzny, and I will be your instructor in this session. The topic for today is route filtering on the ASA. So we will spend some time talking about the different methods we can use to filter out the prefixes depending on the routing protocol used in our network. We will talk about RIP methods, EHRP techniques, and finally take a look at OSPF. Just a couple words about route filtering in general before we start. So, in my personal opinion, this is not a tool that I would use in my network as the only solution to increase the overall security. And there are multiple reasons for it. The first and foremost, this feature works by hiding some certain information from some certain devices. So there will be some devices in our network that will know how to reach the prefixes versus some other devices will not. So depending on where we have our clients connected to and depending from where the attackers are coming from, they may or may not have reachability to those individual networks. Okay, so I would rather treat it as more of as an additional feature that you can deploy in addition to what you have deployed in the past, like when you follow the defense in depth and breadth concept. So just treat it as an additional solution and add it on top of what you already have. Okay, so we will now talk about the individual routing protocol methods that are available on the ASA specifically. Because as we will see, there is going to be a difference between what we have, what we can use on iOS versus what we have on the ASA, and also for certain features, at least one of them, how it works on iOS versus how it works on the ASA. So we will be dealing with, as I mentioned, three routing domains. We will enable RIP between router 7, router 8, the DMZ and the inside of ASA 2. So this is going to be RIP version 2. We also have enabled EHRP between router 10, ASA 4, and router 5. So this is going to be another routing protocol that we run over here. And the AS number is, this is EHRP 145. And finally, we also have OSPF. We will use two areas in this network. Outside of the ASA, the interfaces of router 10 up to 4 ASA 3, and then back to the ASA. This is going to be the backbone. So our area 0. And we will also have, I also enabled OSPF between ASA 1, router 2, and the inside of ASA 3, and this is going to be our area 1. So the OSPF is going to be in red. And we will start our discussion with the simplest of those routing protocols, which is going to be RIP version 2. So we will take a look at routers 7, 8, and ASA 2 specifically. And I want to show you the two methods that we will be able to use over here. This is going to be passive interface. And the second method is going to be, is known as a distribute list. Okay, so let's take a look at the content of the routing tables before we apply any type of filtering in this network. So once again, this is going to be ASA 2, and RIP version 2, router 7, router 8. So router 8 is advertising 3 different prefixes, 888, 0/30, 884, 1088. 7 is advertising 777 and 1077. We also have the catalyst switch, which is this guy here is also part of the RIP domain. And this guy is advertising 888/24. So my expectation at this point is that, for example, router 7, actually let's first take a look at the ASA here. So say show route, and let's take a look at the RIP routes. So we see the prefixes from 7, then a bunch of prefixes from router 8, those, and finally one from the switch, which is 8880/24. So on 7, I should see the prefixes. I can say show IP route RIP from 8 and the switch. On 8, I will see the prefixes from 7 and the switch, because ASA is not advertising anything here. Actually, just the directly connected links. So the first method that I want to show you here, at this point we see that 7 is able to get the routing information from router 8 and the switch. Now, if I want to use this first method, the passive interfaces, this is what's gonna kind of like modify the way the process is gonna work on the interface. Because with our regular configuration, this is the only command that I have put on the ASA under router RIP. So it says that I want to enable the process on all interfaces that are configured with something from the 10 as the major network, which in our case are those two interfaces, the inside and the DMZ. Now, what I will do here is that I'm going to modify the configuration, and I will say that our inside interface, I want to make it passive. Now, when I make the interface passive, it means that I will be still accepting the packets coming from this part of the network. So this is going to be in this direction. My inside interface will be accepting the packets from 7, but I will not be sending anything back out the same port. So I should see that ASA2 is going to still know how to reach the prefixes, the network advertised by 7, but 7 is not going to know about the other prefixes. ASA2 knows it learned them from RIP. So let's go ahead and do this. Now let's go to the process here, and let's say that my passive interface is going to be inside. You can also say that you want to make all interfaces passive, and then say no passive interface and select individual one which you want to make non-passive. So it's just two ways of doing things. You can either configure the passive interfaces one by one, or make them all passive and then kind of like unsuppress individual ones. Okay, so when I now go back to 7, we will either have to wait for those entries to time out from the routing table, or I can simply say clear IP route star, which is gonna trigger, which is gonna force the RIP process to send a request packet with the refreshed routing information. So when I now say show IP route RIP once again, we see that we don't have anything here in the routing table. Show IP RIP database. We don't have any information other than what we advertise in our RIP database. But when I go to the ASA and say show route and look at the RIP prefixes, we see that I'm still getting the networks from router 7. So I made the interface passive on this guy here. Inside is now passive. It means that I will not be sending anything for the inside interface, but I will be still accepting the packets from that I receive on this port. Now, there are no adjacencies or any type of neighbor relationships with RIP, so technically you don't have to form any type of relationship before you start accepting the prefixes. And this is actually what's going on over here. So no adjacencies, no neighborship of any type is being established, and this is what allows the ASA to accept the routes, but once again it doesn't send anything back. So this is our first method, the simplest solution, the passive interface. So 7 obviously at this point, since it doesn't know how to get to this subnet 8885, I will not be able to reach router 8's loopback, meaning that if I had some devices, some clients connected to this segment, they wouldn't be able to reach the clients emulated by those subnets here. Okay, so the second solution I want to show you, the second method we can use for RIP, this is going to be a distribute list. We can go back to the command line here and use this command, distribute list, to filter out the prefixes. Now, the key thing to remember about RIP and EHRP route filtering is that since these two are distance vector protocols, meaning that they simply advertise the content of the routing tables to the onto the segment or to the neighbors in case of EHRP, you can filter the prefixes pretty much anywhere in the network. You can apply distribute lists on a per interface basis, and you can filter out individual prefixes. You just have to configure an access list where you specify what you want to deny or just filter versus what you want to send to the peers. So we will need to create an access list, and let's say that this is the content of the routing table on router 8. Let's say that we will filter this individual prefix. Oh, actually, let's do something else. Let's go back to the ASA. First thing, let's disable the passive interface. I want to make it unpassive. Then let's go to 8. So 7 is now learning about the prefixes we get from 8 and the switch. Now let's go back to 8, and I will try to first thing remove this prefix 10770/24. So this is what's being advertised by router 7, and I will now go to the ASA and say that we want to filter out just this single prefix. I want to prevent it from being advertised onto the DMZ. So this is what we want to use for just one individual prefix. Then 770/24. So I can go to the ASA. I can create my access list. Access list, let's say no 7, where I will say that I want to deny deny host 10770, and then permit everything else. So access list no 7, permit any. Now note that this is a simple standard access list. This is the only one that you can use on the ASA with the distributed lists for both RIP and EHRP. You cannot use extended ones, or even more importantly, you cannot use prefix lists, which is going to have a severe implication. We'll take a look at it in just a couple of seconds. So this is my access list. I say that I want to deny 1077, and I want to permit everything else. I just need to now apply it under the process with the distribute list command, the name of the access list. I will be sending updates to 8, so this is going to be the outbound direction, and interface is DMZ towards router 8. So I apply this distribute list, say clear IP route star. Then let's take a look at the output of the show IP route command, show IP route for RIP. And we see that instead of 1, 2, 3, 4 prefixes, we now get only 3. We don't have that 1077/24 prefix received by router 8. And you can also take a look at this on the ASA. Just say show access list and take a look at the counters here. So we see that we have matches in both lines. So this looks like a perfect solution for filtering prefixes, very granular, and as I said, with RIP, EHRP, you can apply it pretty much everywhere in the network on an arbitrary interface that is enabled for the protocol. But what about if I were to say that I want to filter, say show route, one of these two prefixes? We've got 8880/24. This is what the switch is advertising. I also have another one, which is something that I get from router 8, 8880/30. So the problem here is that the address part of the prefix, or just the prefix itself, is the same. But the prefix length is different. We've got /24 and /30. So one subnet, another subnet with the same address. The mask is different. And this is gonna give us a problem with what we have available, with the features that we have available on the ASA. Because as I said at some point earlier, the prefix lists cannot be used for RIP and the HRP with the distributed lists. We will still be able to use them, but with another method. I cannot use the prefix list for the distributed list. So the prefix list, the advantage of using this one, PL for example, it allows you to not only specify the address part of the network, like 8880, but also the prefix length, like /30. Or even more, you can specify the range of the prefix lengths, like from 24 to 27. So this configuration, this prefix list, would essentially match those networks with /24, /25, /26, all the way up to /27. So that kind of routing updates, this kind of routing updates would be matched by this prefix list, because the prefix list is looking at two elements. One is the address, or just the prefix, and the other one that is treated separately is the prefix length. But you cannot do this with an access list. Like for example, well, one could think that if I say access list, let's say no 8, and where I will say that they want to deny 8880 255. Remember that the regular masks are used on the ASA, not the wildcards. 255, 255, 255, 252. So one could say, or just one could think, that if I build an access list in this way, and then say permit anything else, I will be only matching this individual prefix, with this being the address and this being the prefix length. But this is not going to be the case, because standard access lists, they are always looking at the address part. No matter what you put over here, it is only going to be looking at the address part, which in our case is 8880. This is what we're going to derive when we combine logically and the subnet with the mask. So if I now apply this access list, let's go back to 7. Say show IP route RIP. So as of right now, we are learning about both /24 and /30. If I go to the ASA and apply our prefix list, our access list with the distribute list, no 8, and this time say that they want to filter out the prefixes, outgoing prefixes towards the inside, so towards router 7. So this time I'm on the, I went back to the ASA and I said that they want to apply my list in this direction. I just want to filter out this prefix. As we will see, the result is going to be that I will actually filter out both /30 and /24. So let's go to 7, clear IP route star, and we see that I'm not only seeing the /30 but also /24. So this is what we had before I applied the filter. We got 3 prefixes starting with 888, and then I have only 1 because this is a different address. This is not 8880, it's 8884 as the subnet. So we don't have a match in the access list. Actually, we have, but in the permit entry, and this is why we can only see this a prefix on 7. So it can be a problem with a topology like that when the devices advertise subnets that overlap in the address part. Probably not gonna happen, but just in case, when it does happen, I just want to show you a solution that what you can do on the ASA. Because on router, if this was an iOS router, the situation would be simple. You would go to the router and you would say IP prefix list, like no 830. You would say permit, or just deny, I should say, 8880/30. Then you would say that you want to permit everything else. Permit anything. And then go to the router process, say distribute list, and use the prefix option. And you also have the ability to specify an interface and the direction. But this is not available on the ASA. So we cannot be really granular with this solution. What we could do instead, well, the easiest one would be to modify the network configuration. So one part of the network is going to be running RIP, like between 7 and the ASA. So we would have to modify our routing configuration. ASA and 7 will be running RIP, versus I would be running something else between 8 and the ASA, like for example EAGRP. And then what I could do is that I could redistribute from RIP to EAGRP or on the way back. And when you do the redistribution on the ASA, you have an option to match a route map, where from a route map you can match a prefix list. But instead of dividing this RIP domain into 2 individual domains, I will show you this in action by redistributing from RIP into the OSPF. Because at this point, and one thing that I didn't show you in the beginning of this session, is that since we are running 3 different protocols in this network, we only have reachability within the individual routing protocol domains. So 7 can talk with 8, 8 can talk with to 7, router 2 can talk to router 6, maybe ASA to outside, but OSPF doesn't know about the EAGRP prefixes, RIP prefixes, and so on and so forth. So if my goal was to obtain full IP reachability in this network, which is actually what I'm not trying to show you, because we're trying to filter out the prefixes. We would have to redistribute mutually between those different routing protocols. So maybe just to show you the prefix lists in action, I'm gonna redistribute from RIP into the OSPF, and we will say that we will only redistribute those two prefixes, 8880/30, and maybe let's also redistribute this one, 8884/30. So I don't want to redistribute, I want to filter out this one. This one should stay in the RIP domain. So we can simply create a prefix list on the ASA. Let's call it rad, where I will permit those prefixes /30 and then 4/30, and then we will create a route map, RIP to OSPF, entry number 10 permit, where I will match this prefix list. So this time this is going to be a route map, what is going to control what we redistribute, and specifically the permit entries in the route map. Now, since my route map matches two prefixes in a permit entry, this is what we will redistribute. Everything else is going to be denied by the implicit deny in a route map. So let's go to the OSPF configuration mode, and let's say that I want to redistribute RIP subnets using a route map called RIP to OSPF. So before I do the redistribution, let's go to one of the routers running OSPF. So I don't have any external routes so far. I only have some intra-area and inter-area routes on router 6. And I have those inter-area routes because, as I mentioned, we are using multiple areas in this network. So when I now redistribute on the ASA, we should see two additional prefixes at some point. So instead of seeing all RIP prefixes, I did the filtering because I only said that I want to send just two, 880 and 884. And this is what we get. This is what's now visible in the OSPF domain. So this is like our third method, which is actually going to apply to every single protocol. Redistribution is going to be a valid solution for RIP, EHRP, and OSPF. Okay, so now let's talk about, so this was RIP, and now let's talk about EHRP. So what can I do with EHRP? What kind of methods I can use over here? Well, I still have that passive interface, what I can use, but it is now going to behave differently from what we saw when I was showing you RIP configuration. So, for example, if we take a look at the configuration of, at the routing table of router, say router 5, so this guy over here. So before I apply any type of filters on the device, say show IP route, EHRP, the only prefix I have here is the segment between the ASA and router 10. ASA 4 knows about the prefixes advertised by 5. So what's going to happen when I now go to the process and say that I want to make my inside interface passive? So before I issue this command, we see that I'm getting the prefixes from router 5. I'm going to make the interface passive. So this one over here, this is what I made passive. And when I go back and say show route again, we see that I am no longer getting the prefixes. And router 10 is only going to learn about the connected interface of the ASA between router 5 and the ASA. So it is also not getting the 172, 50, and 51 networks. And the reason is that when you make an interface passive in EAGRP or OSPF, is that the device is never going to form an adjacency with other devices in this segment, and this way will never process the packets with the prefixes, with the networks. So I'm making the interface passive, which means that I will be still advertising the subnet that is associated with the interface, but I will not be establishing any type of adjacencies or forming neighbor relationships for the port, which means that I am not also accepting anything on that port. So this is the first option. Let's disable it. Okay, the other one is a distribute list. And we saw how they work and how we can configure them with RIP. So I will skip this. This is still a valid solution for EAGRP. Something that is available with EAGRP, we don't have it in RIP. This is called distance modifications. The distance command. And so it modifies the administrative distance of the prefixes. So I was not able to use it for with RIP. There is now such a command as distance under the RIP process, but there is one available under the EAGRP process. Distance, where I have an option to specify, to change the administrative distance for all EAGRP prefixes, either the internal ones or the external ones. So it takes two arguments, for internal ones and the external ones. Now, before I issue the command, I want to show you that we are learning the prefixes from router 5. So 172, 5, 50, and 51. And these are the internal prefixes. So if, for example, I wanted to filter out all prefixes, all internal prefixes on this guy here, I could say distance, EAGRP, then say that they are so untrusted that I will not even install them in my routing table. This is when you set the AD to 255, and I'm going to leave the default for external ones, which is 170. So once I issue the command, at some point we should see that this default distance of 90 is going to be changed to 255, and I'm losing the prefixes from the routing table. Now, since I don't use those prefixes internally, I don't even have them in my EAGRP topology table. This means that I will not be obviously advertising this information to router 10. So 10 is also not going to learn about those prefixes. So this is the configuration that I put on this device. I said that everything that I learn internally, I want to remove it from the routing table. You could also modify the distance for external prefixes. If you wanted to remove those, you would have to put 255 over here. Okay, let's just take it out from the configuration. So this is the This is another method we can use, and there is one more that is unique to the to HRP, which is a stub routing. So EHRP stub routing is basically a way to tell the device what kind of prefixes you want to advertise to the neighbors. So show route on the ASA, and then go to router 10, say show IP route EHRP. So as of right now, 10 is learning about free prefixes. 2 from router 5, and 1, which is a segment between the ASA and the router, this one. I can change the ASA4 configuration. I can make it a stub device, and this way tell it this is going to be the EHRP stub command from under the process. What kind of routing information, the prefixes I want to advertise to my neighbors. I can say that I only want to advertise, for example, all connected networks and just them. Maybe just the static routes, maybe the summaries, or maybe I will not be advertising anything. I will be only learning about the prefixes. So when I configure this option, I should see that I will still learn about the prefixes from router 5. But since I am only learning the routes and not sending anything to the neighbors, 10 should lose all 3 prefixes. So the 2 I got from 5 and 1 deconnected subnet. Versus if I say that I want to change the stub configuration to only advertise the connected networks, 10 should at least learn about the subnet between the segment, about the segment between the ASA and router 5, which it does. But it still doesn't learn about the prefixes advertised by 5 because they are not connected ones from the ASA4's perspective. Okay, so finally we've got OSPF, what I want to discuss. And here the situation is going to be different because RIP and EHRP, as I said, these are the examples of distance vector protocols. OSPF is an example of a link state protocol, which means that there is going to be some sort of exchange taking place before the adjacencies are established. That is used to populate the link state database on the OSPF enabled devices. And this whole database, the information about so-called link state, is then used to calculate the shortest paths to the destinations. And the logic here, the way it works, is that all devices within an individual area are supposed to have the same view of the topology. So in other words, they are supposed to have the same link state updates in their databases so they can calculate the same topology. And this has a severe implication, namely you cannot simply filter or summarize the subnets, the prefixes, inside of an area. You can only do this between the areas when you are an ABR, an area border router, which is a device connected to the backbone, area 0, and some other areas, or when you are an autonomous system boundary router, or in other words, a device that does redistribution to OSPF. So ABR for inter-area prefixes, and ASBR for external routes. So the passive interface still feasible, works the same as, so let's make the OSPF configuration in green. So this is a still valid solution for OSPF. A distance is also a valid solution because there is a command we can use, but as we will see, it works differently than on iOS. Because, technically, let's take a look at one of the Let's take a look at ASA 1, which is part of Area 1. This device should already have information in the table, in its routing table, about the external prefixes we have redistributed from REP, which are those two. Now, I also have that command available here, the distance command. So one could think that I can simply say, assuming that I want to filter out those external prefixes, I could say distance OSPF external and set it to 255. So this is what we did with EHRP with the internal prefixes, but it doesn't really matter. We changed the AD to be 255, and we saw that they disappear from the routing table. Now, this is not going to be the case when you use this command on the ASA. So we see that device internally uses the prefixes. It didn't take them out, didn't take them away from the routing table. It basically changed the AD to be 255. And this is a little bit misleading, because if you did the same configuration on, on an iOS device like router 2, let's go to router 2 and let's use the same configuration, router OSPF 1, distance OSPF external 255, say show IP route OSPF. We see that I don't have those prefixes installed in the routing table. But ASA 1 still uses them. So obviously the reason here is that the content of the OSPF database is the same. ASA knows about the external prefixes, external ASAs, and router 2 should also know about them, because the distance command, it affects the routing table, not the link state database. Remember that with OSPF, when you're within a single area, you cannot really modify the content of the link state database. So the feature works differently on the ASA and iOS, and to be honest, I don't really know what's the purpose of implementing the feature in the way we see over here, which is, technically you change the distance to be 255, but it doesn't take it out from the routing table, but it does it when you do this with EHRP. So I'm not really quite sure what is the reason they decided to implement the feature in this way, but either way you can still use it if you want to preempt some prefixes learned from other routing protocols, like if we had another source of information about 8880/30, for example, EHRP, I could use the distance command to say which routing protocol I trust more, and prefixes, and the prefixes that I want to use on this device, but with this command. But you cannot use it to filter out the prefixes. So this is OSPF stuff. Let's also take it out from here. Maybe one thing that I didn't show you, what you can do on iOS, you cannot do on the ASA. Let's go back one step. Let's go back to the EHRP for just 1 second. The distance command, you still have an option to change the distance for all prefixes, the internally learned or the external ones. But on iOS, you can also use an access list to selectively specify the prefixes for which you want to affect. And this first command, the address and the wildcard, this is to basically specify the source of the routing protocol update. So we can be very specific on iOS with what the prefixes you can filter out. You would obviously have to set the administrative distance to 255, not 123. But you don't have this option on the ASA. Same as, for example, you cannot use offset lists on the ASA, but you could use offset lists for RIP on the iOS. Okay, so let's go back to the OSPF. So passive interface, distance, It is available, but kind of like cannot be used to simply filter the routes. What else are we gonna have here? We will have three additional methods, kind of like unique to the OSPF. One is gonna be to use the summarization with the not advertise option. And the other one is gonna be to use filter lists, so not distribute lists, but filter lists. And the third one is to change the type of the areas we use in the network. So this is I'm gonna simply say that okay, let's just call it area types. And specifically, this is gonna be the step area, what I will then show you, and a total step. Okay, but first thing, let's take a look at this method, the filter lists. So once again, I said that with OSPF, you cannot filter within a single area, like for example, area 1. But we can still filter between the areas. Now, our device, ASA 3, is actually acting as an ABR because it is connected to the backbone and to area 1. So this means that I will be able to filter the prefixes, specifically inter-area prefixes, LSA type 3, between the areas on this ABR device. If I take a look at router 2 configuration, the routing table, show IP route OSPF. So we see that we learn about the external prefixes because they are flooded for the entire OSPF domain, but we also learn about the backbone routes. 172.4.30, 172.6.10, 30, and 172.10.20. So let's say that out of those 4 prefixes, I only want to allow to area 1 these 2, 6.10 and 6.30. This is what I want to allow to area 1. So once again, I have to do this on the ABR, ASA3. I can create an access list. Access list, OSPF, permit, 172.6.10. This is the host. And 172.6.30. Then go to the OSPF process, show run router. This is OSPF process number 1. And use the area 1 filter list command. Okay, excuse me, I actually have to use the prefix list, not the access list. So let's quickly create a prefix list. OSPF permit 172.6.10, 24, and 30. Then go back to the process. Area 1 filter list. The prefix list name is OSPF, and I want to filter networks sent to this area. So I said that I will be modifying the configuration of area 1, and this is going to affect the prefixes that I am sending to the area, which is to area 1, so from the backbone. So before ASA3 generates LSAs in this direction, from the backbone to area 1, I will be affecting this process inbound. And let's quickly test this. Router 2, say show IP route OSPF a couple of times. And we see that I am now only allowing those 2. 610, and 630. The 1020 and 430, we don't see them. We don't have them here anymore. So this is the filter list method. And this method only affects inter-area prefixes, LSA type 3. So I couldn't use this method, for example, to filter out external routes. If I wanted to filter out external routes, I am not able to do this on the ABR with this method. I would have to go to my ASBR, so ASA2. This is also an ASBR. ASA2 is also an ASBR because it redistributes RIP prefixes to the OSPF domain. This is what we did previously when I was showing you redistribution. So ASA2 is also an ASBR, which means that this is the point where I can control the networks, the external networks, when they are injected into the OSPF. So I can go to the firewall here. This is my redistribution under the OSPF process. I can go over here and use summarization to say that I want to summarize those prefixes 8880 and 8884. I want to summarize them as, let's say, /24 like this, /24. So what's gonna change now? I should only see one summarized prefix /24 as an external route in my OSPF domain, which I do. This is /24. But if I go one step further and say summary address, leave this syntax and add the not advertise option, this is how you can use this feature, summarization, to actually filter out the prefixes. So instead of generating a summary and instead of injecting individual prefixes, we can filter out everything. So at some point we see that the external route finally disappears. And this is also possible, it is also possible to use this feature when you do the summarization on an ABR. The command is going to be different because this was summary address on the ASBR, what I was showing you previously. Now we will go back to the ABR, which is our ASA free. We will just take out that filter list. Show run router. I want to take it out. So we should still see 4 prefixes, 4 inter-area prefixes on router 2, which we do. And I will not say that I will not filter all of them. So I can simply go to the process and say area, use the area range command. Actually, this is going to be the area 0 range command because now I'm saying what I want to summarize. So I want to summarize the LSAs from the backbone before I send them to all other areas. And I want to summarize the whole, the entire 172/8. I mean, I will be summarizing to the 172/8. So I will have a match in every single prefix because every single prefix from those, it starts with 172. I could be more specific, but it doesn't really matter, in this case. I want to add this not advertise option. And we see that finally the prefixes, they disappear because ABR, ASA free, so APOSPF, database, summary, it no longer advertises the LSAs into the area 1. So this is summarization. This was summarization and filter lists. And there is one more method we can use. Let me just remove this command from the process. Show run router. So this one additional technique is modifying the type of the area. Now, if you take a look at our configuration, the backbone and area 1 is a regular area, same as the backbone. I can simply change the type of the area. I can make it a stub, a total stub, maybe an SSA area, not so stubby area, or even not so totally stubby area. And this is going to affect the type of the LSAs that are being accepted in the area. So for example, if I want to filter out the external prefixes from the whole area 1, well, actually they are all taken out. So let's say that I want to not only remove the external routes, but I also want to prevent LSAs type 3 from entering into my area, which are going to be those prefixes. So I have an option. I can change the type of the area from the normal type to be the total stub, because the stub is going to affect external prefixes. When you make an area a total stub, it is going to affect external routes and the inter-area routes. So we will go for a total stub, which means that I have to change the stub configuration on all of the devices within an area, including my ABR, router OSPF1. I need to say that area 1 is actually a stub, and specifically a total stub. Then I have to do this in router 2 as well. Router OSPF1, area 1 is a stub. And then on the ASA 1, I have to do the same. So show run router, area 1 is a stub. So at some point, the adjacencies should reestablish show IP OSPF neighbor. So we see that the adjacencies are up. And if I say show IP route OSPF, I don't see the specific type 3 LSAs. Instead, I just see a single default route that is actually type 3 LSA advertised into the area. But I have filtered out the individual prefixes from the area. And once again, this method, the area type, you can use it to affect just the external prefixes, or maybe both, the inter-area and external routes. Okay, and finally, the last option I would like to show you here is to use redistribution, and one feature that is available on the ASA specifically, namely the ability to create 2 different OSPF processes on a single firewall. Because for RIP and EIGRP, you can only have one instance of the protocol running on the device. But you can have 2 OSPF instances running on the ASA. So instead of configuring the network by using 2 areas, area 1 and area 0, we will now modify this configuration. We will be using just the backbone, just a single area over here, and between the ASA 2, router 610, ASA 3, and router 4. But we will say that this is OSPF process number 2 between ASA 3, router 2, and ASA 1, versus this is going to be OSPF process number 1. So what is going to be the difference here? Let's reconfigure the devices. Let's start with ASA 1. So no area 1 stub. Show run router. Router OSPF 1. Okay, let's take it out. Now let's just change the area to be 1, to be 0. Let's do the same on router 2. No area 1 stub. And then the interface is IP-OSPF 1 area 0. And the same on the other one. And finally on ASA 3. On our, so this was previously an ABR. We will now remove this command, put it back in, but with the backbone. So this is no longer an ABR. We just have a single area in this network. Show OSPF neighbor. But actually, this is process number 1. Router OSPF 1. Let's remove this command. Router OSPF 2, and then put it over here, area 1, area 0. So this is what we have in the configuration here. I've got 2 OSPF processes. The old one, which is running between on the outside of the ASA, and I've got another process that is running on the inside between 2 and the ASA 1. So when I now say show IP route on router 2 for OSPF, we see that 2 is not learning about anything, because it is directly connected to this subnet and that subnet. It doesn't learn about those for OSPF, but ASA1 should still learn about the 172.230. So we should at least see one prefix learned for OSPF over here. It says that this is the subnet. Actually, there is one more. There is also a loopback configured on router 2. Let's make it an intra-area route. IP-OSPF 1 area 0. So ASA 1 is learning about 2 OSPF networks. And ASA 3 is going to have information about all networks on the inside and also on the outside. So for example, 172.4.30, or maybe this subnet over here. And the way that I have separated this configuration, what this allows me to do is that if, for example, I had the private ranges configured on the inside. If this was my RFC 1918 ranges, what I used here, I don't really want to advertise those prefixes to the outside. Maybe I'm doing the network address translation. I may still have some private ranges that I want to advertise, but again, I don't want to advertise my RFC 1918. So I cannot simply say redistribute OSPF2 under process number 1. So in this direction, because it's then gonna redistribute all prefixes, I can be more specific and select the prefixes for redistribution. In the exact same way as what I was showing you when we were redistributing from RIP to OSPF. So I could go to ASA3. Once again, I have 2 processes now which don't share a database. If I say show OSPF database, we see that the link state databases are separated. There is one for process 1, there is one for process 2, and by default, those link state databases, they don't share any LSAs. So this is why our internal devices, they don't know about the outside OSPF domain. So I still have an option to exchange the routes, but I have to redistribute between the processes. So I can create my access list or a prefix list. Let's see, prefix list loopback L2, as for loopback 2, and say permit just this one. Then route map to process number 2 to process number 1, entry number 10, match IP address prefix this. This is my outside process, this is my inside process. So I need to go over here and say that I want to redistribute OSPF subnets, OSPF process number 2 subnets, using my route map, where a route map is called 221. So when I do this, we should see that it is going to learn about just one external route, which is 2.2.2.2. So this is this device over here. It learned about the loopback, but it didn't learn about this segment and that segment, because this is not what I matched with my prefix list in my route map. Okay, just in case if you're looking for some additional free training from iPexpert, you can always visit our blog and YouTube channel. For any type of news and promotions from us, you can visit us on Facebook and Twitter. In case you have any questions to this demonstration, you can always reach me at piotrk@ipexpert.com, or you can simply ask me the questions now after the session is over. So if you have some questions, you can simply type them in the chat window, and I will try to answer them. Thank you for watching.